Welcome back everyone. This is the Q&A session 7 from the playlist of circular motion. The topic is the net acceleration, and this session um, is related to the session number 2, in which we have studied about the dynamics of circular motion. So in that session number 2 we have derived the equation for the resultant acceleration, which was equal to the net acceleration was equal to AC square plus AT square, where AC is the centripetal acceleration and this AT is the tangential acceleration. So this question is based on that session. So all of you can go through that session. That is it is the session number 2, and I have taken that session long time back. So this question is based on this formula, that is the net acceleration is equal to the under root of the centripetal acceleration, the square of the centripetal acceleration plus the square of the tangential acceleration. So here a cyclist is moving with a velocity of 7.5 meter per second. He approaches a U-turn of radius 80 meter. He applies the brake to slow down at the rate of 0.5 meter per second square. So we have to calculate the acceleration of the cyclist at the U-turn. So here let us say this is the point P at which the cyclist applies the brake. So at this point P, the velocity of the cyclist will be 7.5 meter per second. So this is the velocity of the cyclist, and so when he applies the brake at this point, when he approaches this U-turn of radius 80 meter, then what will happen? The tangential acceleration will be acting in the opposite direction of this velocity. So the direction of this tangential acceleration will be as indicated by this arrow. Now when he will take this U-turn, then centripetal acceleration will also be will come into existence, and the centripetal acceleration will be directed inwards, that is towards the center of the radius of this U-turn. So the net acceleration will be equal to AC is the centripetal acceleration and AT is the tangential acceleration. Now we have to find the value of AC. Now AC, the centripetal acceleration, as we know that this is given by V squared by R, and this is I have already discussed about this in the session number 2. So V is equal to 7.5 into 7.5 and the radius is given as 80. So if I solve it, then the value will be equal to 0.07. So this is equal to 0.7, approximately it is 0.7 meter per second square. Now the tangential acceleration will be equal to 0.5 meter per second square, and it will be acting in the downward direction, that is in the direction opposite to the direction of this velocity. So A will be equal to under root of 0.7 whole square. This 0.7 is the value of AC plus AT is 0.5 square, and the this resultant acceleration will be the direction of this resultant acceleration will be somewhere like this. Okay, it will be passing between the direction of this centripetal acceleration and the direction of the tangential acceleration. Now, so this is equal to under root of, this can be written as 49 divided by 100 plus 25 divided by 100. So this can be written as under root 73 divided by 10. So the net acceleration, or you can say the resultant acceleration, will be equal to under root 73 is equal to 8.5 approximately divided by 10. So the resultant acceleration is coming out to be approximately equal to 0.85 meter per second square. And the direction of this resultant acceleration will be between the direction of this AC and AT, and since the value of this centripetal acceleration is more, therefore it will be slightly towards this centripetal acceleration. So thank you very much for joining this session. In the next session, we will be coming up with a different topic, and the topic definitely will be the same, that is circular motion. So till then, have a nice day. Bye.